Hi, let's take a look at this one, the hexagon that you asked me about. So for this one, I'm hoping that you were told that this was a regular hexagon. That would be important. You would need some information that either says the word regular or something that indicates that all 6 sides are congruent, or all of the, and all these angles are congruent, so that we would know, that we could actually solve this. So we would need all of those things in order to do this, but so I'm guessing that you know that, that you've been given that information. And so one of the first things I would do is I would just draw lines to kind of see that, okay, this hexagon is actually 6 triangles that are congruent. They're the same. They're congruent to each other. So that means all of these sides are 18. And just to make it easier to kind of look at, I would say that this side is 18. And so I would do one more thing after that, and that is that I would think about the inside here. These are all central angles. If you think of this as a circle, and I'm not sure if you've done circles already, but you would kind of need that in order to do this problem. So I hope so. So, the measure of a circle is 360 degrees, and central angles are equal to their central arcs. And so anyway, these little angles inside here would all be whatever 360 divided by 6 is, because they would all be the same measure. So based on that, these are 60-degree angles. So I'm going to take the circle off just for the sake of space here. Okay, so I know that this is a 60-degree angle here, and all of the angles around are 60 degrees. Okay. So then what I would do is I would come to the center, and I would sketch an altitude. And so I know that the altitude is going to be perpendicular. So that's a perfect height. And I know that that cuts this side in half. So it was 18 all the way across. So now this is just 9 and 9. I'm just going to write it one time because I'm just going to look at this triangle on the right side. It also cuts this angle in half. So if this was a 60-degree angle, it's now a 30-degree angle up here. And so we've got a right angle and a 30-degree angle. So we're looking at a 30, 60, 90 special right triangle. And I know from last week's problems, yeah, with circles. So you have seen circles before. That's right. Okay. So with last week's, I saw that you were doing a little bit with special right triangles to solve a different problem. So, so you know how to do this. We're working toward, if we can find the area of this triangle, then we can find the area of both of them, and then we can find the area of all 6, and that would lead us, of course, to the whole hexagon. So for the area of a triangle, we need 1/2 of the base times the height. And so we already know the base is 9. We just need the height here. So think about, 9 is the short leg, and this would be the long leg because it's across from the 60-degree angle. So the long leg is the short leg times the square root of 3. So the long leg is 9 times the square root of 3. So 9 times the square root of 3. Okay, so think about that. That is our area of our triangle. So that would be 81 times the square root of 3 divided by 2. 9 times 9 is 81, and then it's all divided by 2. The reason I'm leaving it like this is because remember, this is for this triangle. If we multiply by 2, then we'll have both of those triangles. So if I multiply by 2, it works out nicely as far as the math goes, right? To give us 81 square root of 3. And so that's for one triangle, that's the area. And we need all 6. So I would multiply that by 6. So I'm going to show you on the calculator what that looks like. Pull it up. Let me kind of scoot it out of the way. So 81 times the square root of 3 times 6 triangles that have that area gives us 841 and 78 hundredths. So that's the approximate area here. I don't know if you what you have to round to, and that is square feet. All right, I hope that was helpful. And yeah, let me know if you have questions.